So now let's look at the more complicated side of the project, and that is the part that runs all of the other open source code. So if we take a look at the architecture first, that might help. So technically all of the code that we use for the open source analysis could run on the Android, but we didn't make it run on the Android because it was easier for us to use it where it's designed to be used, which is in a Mac or a Linux environment. It does run in Windows too, but you have to adapt it a little bit to make it work. So all of this could run on the Android, which is why we wanted to use an Android, so that we could do the data analysis and extraction immediately and show the results to the participant. But because we didn't have a lot of time for the project, we kept a simple route where the Android does all of the recording and the laptop does all of the analysis. So let's look at the projects that we integrated. So when you're done the experiment, you can either drag and drop the files to your laptop or use Wi-Fi with the backup service to save it to the laptop or a server if you're using a server. You just need the IP address of the computer. So basically we're using Node.js to present a web interface to make it easier for you to use, but all of the code is here in the back end. And if you know how to run a bash script, then you can run that independent of the web interface, which is how I run it because I like scripting instead. I like the command line, but not everyone likes to use the command line. So quickly, we have a file called audio to text, which makes the audio and makes it into text. So it takes the 3GP video, runs it through FFMpeg, which makes a WAV file. The WAV file is read by Sphinx. We're using the Lattice demo with the Wall Street Journal language model to recognize the text and create a subtitle. Now this language model is for the Wall Street Journal, which is not a representative language model for the bilingual aphasia test. So if we made a language model that represents the speech in the bilingual aphasia test, then we would have better accuracy. Right now the accuracy is terrible. But now that we have ran 17 participants, we have a small corpus, and we can create a new language model which represents more accurately the possibility of the language in the test. And then also the WAV is read by this file, which finds syllable nuclei, which is an open source Praat script we found online. And the output of that script is text grids with the syllable nuclei on a point tier and silences and sound using Praat's integrated functionality to find silence for you so that you have less work to do when you're doing transcription or something like that. Let me try to zoom in so you can see this more closely in the text grid itself. So yeah. So here, these are some syllables which the script found, which were accurate. This is one that it found which was not there. So it's about 80% accurate. There are some syllables which it found that I removed. And I added the transcription afterwards using the silent and sounding periods to save myself time. So after we got out the text grids, we also were able to have the articulation rate and speech rate, which is a calculation of syllables per phonation or syllables per audio file to determine the fluency or the comfort level of the speakers. So we have that data here, which we plotted using R. So we included the R script, which also has some t-tests in there if you're interested. So the R script outputs PDFs, which are what those are. And basically all of that goes through Git and versioning control on your hard drive so that you don't lose any data. So even if you delete files by mistake using your mouse, the files are still there in the backup. The other file which is running on the laptop is called SRT to touch, which takes subtitles and creates touch data points in JSON format, which is what we're using for this little script that I wrote in JavaScript. It took me a couple of days to make a JavaScript touch visualizer, which there's another video for you can see online. Yeah, we also have OpenCV in the project, and that's to analyze the eye gaze, but we're still learning how to use it. It's a really complicated open source project, so you could help us with that if your developer knows more about OpenCV. So now let's take a look at the repository itself. It's on GitHub, and it's here. It's mostly written in JavaScript, but there is some bash scripts in there which we used to glue the projects together using the command line. Okay. So the Praat files are in here, the R files are there, the Sphinx are in here, so that way you can take a look at them separately. Again, this is the poster which will give you the architecture and also the results. That's this file. And yeah, so you can see one of the most important things I think about a repository and what's useful about GitHub is that you can see the age of the file. So you can see if we edit the file frequently, it's a really important file. But if we don't edit it frequently, it's probably a dead file that's still hanging out from old stuff. So you can kind of tell that from the architecture because there's some files in the architecture that I didn't include, which are still in the repository, like the install and the server. Well, those are actually useful. That's how you install it onto your laptop. So it does come with an installer which you can download, and you can install it on your Mac. I can't guarantee that it'll work. It's kind of buggy because it's only like a week or so old. But yeah, this is the installer. It's a package which runs the installation.